For the quotient rule, it is very similar to the product rule, although instead of first and second, you have top and bottom. And you're going to follow a similar pattern, top and bottom, bottom and top, but instead you have a minus in the middle, and then it is over whatever is in the bottom squared. Let's take a look at an example of this being done. So I found the derivative of the top of this quotient, and then I multiplied it by the bottom part of the quotient. There's always a minus in the middle of quotient rule. Then I found the derivative of this bottom piece, which is 2, and multiplied it by the top. Done. And then it's always going to be over the bottom squared. Then you would go through some simplification steps of that, so I can distribute those things together, do a little more distributing over here, and then combine that numerator up so that you can get to what is a somewhat simplified. Remember, we're not huge on simplification, but we can do a little bit of cleaning up just to make sure that we're in practice for those multiple choice options. But then this would be the derivative. Now, with quotient rule, unlike product rule, dive right in, go nuts, do it, it's fine. Quotient rule, be a little careful. Here's why. Check this example. Don't write this down. Oh no, this got messy. So I did the derivative of the top and the bottom, and it was a foiling mess. But I have an idea to make this a little bit better. So instead of doing all this, keep in mind this. I'm going to steal this actually. So give me this, copy that. I'll go to a fresh slide, and I'm going to keep that same thing. So remember that mess that was just here. Watch what we could do. I could look at that polynomial and I could say, hey, I could factor that thing in order to make it look a little bit neater. So I could make that an x plus 3 and an x plus 2 over an x plus 2 and an x minus 2 by doing a little bit of factoring, right? Cancel, cancel. And now we just have to find the derivative of x plus 3 over x minus 2. Okay, it's still a quotient rule, but the derivatives of what I'm about to find are a lot simpler than the derivatives I was going to find before. So now when I do the derivative of the top, it is just a 1. And when I do the derivative, do the bottom, minus the derivative of the bottom, which is just 1, times the top, which is an x plus 3, over an x minus 2 being squared. Okay, so now my numerator is just x minus 2 minus x minus 3 over an x minus 2 being squared, which is the exact same thing as what I had on that previous slide. Look at the difference between these two things, right? So all of that versus what I did just here. I wrote twice as big on this slide as the previous one. So when you're doing that quotient rule, think about what you can do to simplify things down. It is still true that x cannot be plus or minus 2. We need to include that to say, hey, by the way, in our derivative, we still can't have plus or minus 2, even though I canceled out the minus 2 that had been there before. Cool. Carrying on with that idea of when you can do quotient rule, it can be even helpful in simpler situations like this. So rather than doing quotient rule on this thing, I could say, hey, well, using my powers of exponents, I could rewrite this expression. This is a much simpler one, but it still is helpful. This is a 2 x to the, let's see, 1 minus a third, that's going to be 2/3. And then I can just use power rule on this thing. So y prime is going to be 4/3 x. And I got to subtract 1 from that, so that's going to be negative 1/3. So then this final answer, our simplified version, is y prime equals 4/3 to the 1/3. You could make that a cubed root too if you wanted, but that is doing the power rule is way simpler than having to do the quotient rule on that. So whenever you're looking at quotient rule, think about, can I make this a little simpler for myself? In this example, I want to think about, okay, well, can I make that a little bit simpler when I'm finding the derivative? Because I need the equation of the tangent line. Equation of the tangent line needs the slope at any point, so I need the derivative of that function. So I need to figure out what f prime is. Could I simplify that? Yeah, I could. I could make it f of x be x times x plus 4 to the negative 1, but and then do like product rule. I could if I wanted to. I don't want to. I would rather do one with quotient in this case. It's a bit of 6 to 1, half dozen to another. You decide the one that you like better and you just go with that. So I need to figure out what f prime of, and I'm going to make it even simpler for myself. I'm going to directly put in that negative 5. So whenever I write an x, I'm going to put a negative 5. So the derivative of my top is going to be 1 times whatever's on the bottom. So it's x plus 4, but instead of an x, I'm going to write a negative 5. This is just in the service of going faster, because not only do we want to be accurate on the exam, we also want to be fast. And this is just faster. Derivative of the bottom is going to be 1 times whatever is on the top, which is just an x, but I'm replacing all of my x's with 5s. All over whatever is in the bottom squared. And what's in the bottom is an x plus 4, but I'm going to put a negative 5. I think I've been saying 5s all this time, but I'm actually putting in negative 5s now, aren't I? All right, so negative 5 plus 4, that's negative 1. And then negative 1 times negative 5, that's plus 5. Over negative 1 being squared. So that is, let's see, 4. So the derivative at that point is 4. So the equation of our tangent line is going to be y minus the y value, right here of 5, equals the slope of our tangent line at 5, which is 4, the derivative at negative 5, which is 4, x plus 5. And then we can plug that into our graphing calculator and make sure that we get the same thing. So to verify what we were getting, I got a 4 when I typed it into the calculator. Again, it's off by a little bit. And then I also graphed the 2. So here is my original function. And then I did the derivative at negative 5. And I put this other stuff in here too. It's over to the side, but we don't need to see that. And then here's our graph. So there's the original graph. And then here is our tangent line pinging off that point at negative 5, 5, and only touching the curve at that single spot. Great. That concludes our video on product and quotient rule. Reminder that for the product rule, you do the derivative of the first times the second with a plus, and then the derivative of the second times the first. However, quotient is kind of top and bottom instead of first and second, uses a minus, and it's over the bottom squared. You can do the derivative of a sum, just like do the first and the second, do the derivatives of fine, but product and quotient require these rules in order to be able to find our derivatives. Thanks for watching. Goodbye.